x is a decreasing function, and if fx is a decreasing function, gx is a decreasing function, then fog x is an increasing function. Now you must be thinking how to remember this table. Now I'll tell you a technique. It's very easy. If I say that increasing is denoted by a positive sign, again increasing would be denoted by a positive sign. If we multiply a positive with a positive, what we get? Yes, we get a positive quantity. Therefore, if fx is increasing and gx is increasing, we get fog x as increasing function. Similarly, fx is taken as increasing in this case, and decreasing is denoted by negative. Then what do we get when we multiply a positive quantity with a negative quantity? Yeah, we get a negative quantity. So fog x becomes negative in this case. Now if I say that fx is a decreasing quantity, that is, it is with a negative sign, and gx is an increasing function, so this is positive. So again, negative into positive is a negative quantity. And similarly, if fx is decreasing, then negative, and gx is also decreasing, then again negative, and so fog x would be an increasing function. Thus it's very simple to remember this table. Why does this happen? Let's try to look at the proof of this. So let's first of all suppose that x is greater than y. Now if g is an increasing function, then gx would be greater than g of y, and f is an increasing function, therefore f of g of x should be greater than f of g of y. This is because we see that g of x is greater than g of y, and hence we can say that this is an increasing function. The second is, if g is a decreasing function, then again we know that x is greater than y, so g of x would be less than g of y, and also we know that f is an increasing function, so f of g of y would be greater than f of g of x, and so we say that this is a decreasing function. The third is, if g is an increasing function, again x is greater than y, and so g of x would be greater than g of y, and we know that f is a decreasing function, so f of gx should be less than f of g of y, and thus we see that this becomes a decreasing function. The last is, if g is a decreasing function, again x is greater than y, then g of x would be less than g of y, and we know that f is a decreasing function, so f of g of x should be greater than f of g of y, and because this happens, so f of g of x becomes an increasing function. So let us see an example. The function fx equal to e to the power of minus x is a decreasing function because it is a composition g of h of the increasing function gx equal to e to the power of x and the decreasing function hx equal to minus x. So fx equal to e to the power of minus x is a composition function of gx, that is e to the power of x, and the decreasing function hx equal to e to the power of minus x. But the composition we see here is a decreasing function. The third property is, if fx is a strictly increasing function in the interval a comma b, then f inverse exists, and also f inverse x is a strictly increasing function on the interval a comma b. We have studied this rule in our chapter on functions. So it says that if fx is a strictly increasing function in any interval, then f inverse exists, and that f inverse x is a strictly increasing function on the interval a comma b. So we have studied the different properties of monotonous functions. Now let's try to solve an example. This problem appeared in IIT JEE 1996, and it says that fx is a function which is defined as fx equal to x into e to the power of ax, then x is less than equal to 0, and fx is equal to x plus ax square minus x cube when x is greater than 0, where a is a positive constant. Find the interval in which f dash x is increasing. So in this problem we have been given the function fx, and we have to find the interval in which f dash x is increasing. Earlier we used to find the interval in which fx was increasing or decreasing. But now in this problem we have to find the interval in which f dash x is increasing. So let's just quickly look at the solution of this. We have been given that fx is equal to x into e to the power of ax when x is less than equal to 0, and is equal to x plus ax square minus x cube when x is greater than 0. We are going to define the function f dash x. So we differentiate fx to get f dash x equal to, we differentiate this part and get a into x into e to the power of ax plus e to the power of ax when x is less than equal to 0, and is equal to, we differentiate this part and get 1 plus 2ax minus 3x square when x is greater than 0. So this is the function f dash x. Now we have to find the interval in which f dash x is increasing. So this is our function and we have to differentiate it again to find the interval in which it is increasing. We differentiate this part and get 2 times a into e to the power of ax plus a square into x into e to the power of ax when x is less than equal to 0, and we differentiate this part to get 2a minus 6x when x is greater than 0. This is the expression for f double dash x. Now f dash x has to be an increasing function, so f double dash x should be greater than 0. Now we see that f double dash x is equal to 2 times a into e to the power ax plus a square into x into e to the power of ax when x is less than equal to 0. Now we take e to the power ax and a common from this and get f double dash x equal to a into e to the power of ax into 2 plus ax. Now a is a positive quantity and this is also a positive quantity, so we have to look for this expression. Also f double dash x is equal to 2a minus 6x when x is greater than 0. So when we solve these two expressions we get two critical points, that is x equal to minus 2 by a and x equal to minus a by 3. Now when x is greater than minus a by 3 we see that f dash x is decreasing function because f double dash x is less than 0. Similarly when x is less than minus 2 by a, then f dash x is again a decreasing function because f double dash x is less than 0. But in the interval between minus 2 by a and minus a by 3 we see that f double dash x is greater than 0, and so f dash x is an increasing function in this interval, and so f dash x is an increasing function in this interval. So we can say that f dash x is an increasing function in the interval minus 2 by a comma minus a by 3. Now let's come back to the theory, and this is the last part of this lecture, that is comparing functions. Now we are going to see how we use the concept of increasing and decreasing functions to compare two functions. Whenever we have to make a comparison between two functions fx and gx, we take any function hx equal to f of x minus g of x. Now we check whether hx is an increasing function or a decreasing function. Whenever we need to make a comparison between fx and gx, any two functions, then we take another function hx equal to f of x minus g of x. Then in the next step what we do is we check whether hx is an increasing function or a decreasing function to make a comparison between the two functions fx and g of x. Now how we do it? Let's try to see it through examples. So let's see an example. It appeared in 1987 and it is the set of all x for which log of 1 plus x is less than equal to x is equal to. So in this problem we have to find the set of all x for which this inequality holds. So let us say that hx is equal to log of 1 plus x minus x. Your log of 1 plus x is one function fx and x is another function gx. So h of x is equal to f of x minus g of x, which is equal to log of 1 plus x minus x. Now the first step is we differentiate hx with respect to x to know whether hx is an increasing function or a decreasing function. So when we differentiate h of x, we get h dash x equal to 1 by 1 plus x minus 1, and which is equal to minus x by 1 plus x. Now the value of h dash x is equal to minus x by 1 plus x. Now if we say that x lies in the interval -1 to 0, that is x is greater than -1 and less than 0, then we see that h dash x is greater than 0, and so h of x is an increasing function. Thus when x lies in the interval -1 to 0, we see that h of x is an increasing function. Now also, as x lies in the interval -1 to 0, therefore x is less than 0, or h of x would be less than h of 0 because hx is an increasing function. Also, when we put x equal to 0 in this expression, we get h of 0 equal to 0. Therefore, x is greater than log of 1 plus x when x lies in this interval. Now if we say that x is greater than 0, then h dash x would be less than 0, that is hx is a decreasing function. Also x is greater than 0, therefore h of 0 would be greater than h of x, as hx is a decreasing function. Again we get the inequality, that is x is greater than log of 1 plus x. And also we see that when x is equal to 0, log of 1 plus x would be equal to x, and hence from this we get x is greater or equal to log of 1 plus x if x is greater than -1. So for all x greater than -1, we get the inequality x greater or equal to log of 1 plus x, and hence we have got the result. Let's try to solve one more problem. This problem appeared in IIT-JEE 2003. Using the relation 2 times 1 minus cos x is less than x square, where x is not equal to 0, or otherwise prove that sine of tan x is greater or equal to x for all x in the interval of 0 to pi by 4, including the points x equal to 0 and the point x equal to pi by 4. In this problem, once again we have to prove that the function sine of tan x is greater or equal to x for all x lying in the interval 0 to pi by 4, and using the relation 2 times 1 minus cos x is less than x square. Your x is not equal to 0. So let us say that fx is equal to sine of tan x minus x. So the next step would be we differentiate fx with respect to x, and so we get f dash x equal to cos of tan x into sec square x minus 1. Now we know that sec square x is equal to 1 plus tan square x. This is a trigonometric identity. So we substitute sec square x equal to 1 plus tan square x and get cos of tan x plus tan square x into cos of tan x minus 1. So when we substitute sec square x equal to 1 plus tan square x, we get this relation. Now we have been given that 2 times 1 minus cos x is less than x square, or 1 minus cos x is less than x square by 2. From this we get cos x is greater than 1 minus x square by 2. Now we see that x lies between 0 to pi by 4, and hence if we substitute x by tan x, then cos of tan x is greater than 1 minus tan square x by 2, or cos of tan x minus 1 is greater than minus tan square x by 2. So now we are going to use this relation to get f dash x is greater than tan square x into cos of tan x minus tan square x by 2, because cos of tan x minus 1 is greater than minus tan square x by 2. So f dash x is greater than tan square x into cos of tan x minus tan square x by 2. We take out tan square x common and get f dash x greater than tan square x into cos of tan x minus 1 by 2. This is a positive quantity, and because x lies in the interval 0 to pi by 4, we get cos of tan x